current versus direct current. Okay, so there's a lot of benefits of alternating current. Direct current is what the power lines are generally, and you see the commercials all the time, not to touch a down power line because of the danger of it. Mm-hmm. So the benefits of alternating current. So this one is definitely true, that it steps up and steps down for sure. So I'm not seeing like the ones I want here. Like there's conversion to direct current, which is very good. That I'm not seeing that here. So it can definitely travel long distances. Okay. So as a result, it can be transmitted more safely. And I guess I'm going to go with all of them. I mean, I couldn't say for sure, but feels like they could all be true here. So the point is alternating current is better than direct current in most cases. Direct current is like a battery, whereas alternating current's when you plug in something in the wall, that's what you're getting.
Okay.
So, okay. Okay, which of the following function best with direct current? So I mentioned a battery, so that's why a flashlight would be ideal. Boy. Again, he's kind of like, well, which ones, what do they mean by that? So hair dryers operate at pretty high voltage. I think it's going to be a direct current situation because they operate at high voltage. Now, computer mouse, like if you have one with batteries inside of it, I'm going to say yes to that. And then dishwasher, I don't know why that would be on there. I don't think so. So I think that's probably going to be omitted. It's an odd one there anyway, but I think the reasons for those: flashlight or batteries, hair dryer is high voltage, and the computer mouse is, well, you put batteries in it. So you can go with that as an explanation here for it.
Okay.
Next question here asks about loops. That one put in here. So we talked about primary and secondary. So primary has 54 loops, and that's 9 volts. And a secondary has 45 loops. So less loops, less voltage. And so you could, excuse me, you could create there's a couple ways to do it. You could create a ratio, but really you just need to know like how much less it is. So we need to figure out what is 45 divided by 54. And then we're going to multiply that by the 9 volts. So if you got a calculator handy, you could do this, but it's most likely going to be that 7.5 volts.
Okay.
And it is. It's that 7.5 volts, because if this steps down, then this also has to step down, and obviously it's not half the number of loops. It's just less loops.
Mm-hmm.
All right. So in the previous lesson, I gave you an example of a step down, step up transformer, that it wasn't the green box. Most people that own homes, they try to avoid homes where they've got one of these. Sometimes they can't. This is a smaller version, but this is a transformer. This is the type of transformer that's supplied to the home. And
Mm-hmm.
but what is the okay direct current transformer? That's weird. So okay, sorry, I'm just trying to find the answer. Oh, there. Okay, so it's the one that lowers the voltage, because it's running, and that's why it's actually running underground. It lowers the voltage from the higher, and increases the current. Supplied to the home. Is that okay? Is that clear?
Yeah.
Okay, keep going here. All right, so next one is just a straight definition here. Let me snip it in. Which of the following electrical components is a temporary electrical energy storage device? That is a capacitor. It's just a pure definition what it does.
Okay.
Okay, we'll continue here. Select 3 possible applications of a capacitor. So again, there's some that seem obvious, like the flash camera flashes. It does store up charge to be able to do that, because you need a lot of. We don't use our flash very often. You need to store up a lot of energy to do that.
Mm-hmm.
And but otherwise, so your motor starter. Oh boy. These might have been examples given in the lecture notes. So again, if you ever have time to review those or those videos, I know they aren't that helpful, but it could help us here to answer some of these.
Okay.
Let's see here what I can come up with. See, there's capacitors and everything. So it's like, what do you mean? So I guess I would go with these three. The test meter has it's just measuring things. It doesn't actually care. It doesn't have to build up a charge the way the other ones do. The flash has to build up a charge to work. Your computer battery holds a charge. That's why it's able to power your device. The starter in your car holds a charge to be able to turn over the engine if you have a gas-powered vehicle.
Mhm.
Okay, next question here. It says, which of the following electrical components protects your home from excessive flow of current in the electrical wires? Not just your home, it's actually your car as well. Your car has a fuse box. And in your home, you've got a panel. It's usually outside in Arizona, which is really odd. And sometimes they're labeled. So if you plug like your hair dryer and another hair dryer and another thing into your outlet, sometimes it trips it and you got to go outside and flip it. We usually call it a breaker, but it's a circuit breaker, but I guess they're referring to it here as a fuse, which is what you hear in your car. Although with electric vehicles, they may be doing something different.
Okay.
All right, a current of 8 amps is used to operate a coffee machine. Fuse size from the following. So let's just say you went with a 5 amp fuse. My understanding is that that would cause it to trip when it's operating, which is no good. Same with the 3. The 10 would not, the 13 would not. And I guess they're trying to say like, well, what's too much? So the 10 amp is just enough to sort of let it operate, not run wild on power.
Okay.
All right, which of the following provide alternating current? So the main one that is your power outlet in your home. Almost everything you plug into your power outlet is AC. Now you're like your iPhone charger or if you got that wall wart, that thing you plug into the wall, that converts it to DC. But your power receptacle in your house is AC. I mean, none of this really matters to us, me, whoever. But there are, if you were to go into like physics or engineering or science, like you would care about this stuff. And it's a primary question, what's going to power a device? It's going to be alternating current or direct current. But in your home, it's alternating current. Batteries are almost always DC. Solar cells are almost always DC. So I don't know if you have solar on your home, but there's always a converter to convert it into AC. They call it an inverter, if you've seen that. I don't know why microphone is there, but microphones don't power things. So I think that's probably your best bet there.
Okay.
Another which of the following. These are great for people who write questions, terrible for students who have to answer them because you got to look at all of them.
Yeah.
Okay. All right, let me search these one by one to give you some better answers.
Okay.
So, okay, the answer, this is tough because there's sort of like the completely correct answer, and then there's what I would guess here. The primary, the one we know for sure is this one here, is that's correct, is this third one. Direct current is the one where electrons flow only in one direction, and alternating current, they can, hence the word alternate, they can change periodically. Okay. This first one is a no because of it's moving. There's some motion. The last one is tricky, and that's what I meant by the sort of like the most common representation of a wave is a sine wave, but there's other waves that there's square waves, there's triangular waves, there's sawtooth waves. So I'm sorry. Again, like if you have the ability to go, if you have like a lecture reading, that's where you would start searching for some of these types of things.
Okay.
To see if, either word for word, or you might look for the word waveform. That might help you to answer some of these more completely for the, for the full grade on stuff.
Okay.
But that's the best I've got there for that. Okay, so that takes us to the end of email number 1. I know there's more, so I'll keep going here. All right, so it says how does a circuit breaker disconnect a circuit during high current flow? This is what I was talking about when you plug a lot of devices into an outlet that overdo it. I actually don't know the answer, but we do know that it causes the break. I want to say it's this last one here about capacitors, but let me just double check. I mean, this is the kind of thing, you don't know, you just go and flip it back. So let's see here. Okay, so apparently there is an electromagnet. I thought it was a capacitor. I had to look at an image of one. There is an electromagnet that pulls the connection apart. So we'll go with that.
Okay.
Okay, so circuit breakers are more convenient than fuses. So one of the earlier questions that we kind of compared them to be the same. When your fuse pops in your car, you have to replace it. If you go to your circuit breaker, you just reset it. They generally don't need to be replaced. They absolutely protect people from shocks. Do they offer more protection? I'm not sure. I guess I probably would, just the way these are written, I'd probably go with all of the above there in that situation.
Okay.
Be right back. All right, I'm back.
Okay.
Okay, so we got a bunch of symbols here. Grab a few of these at a time. These are similar to what we did last week, so there's not going to be anything new here. Let me grab the others. All right. Oh, and then your book's kind of pointing out that there's different symbols depending on which country you're in. That's even more fun. If you someday maybe you'll work somewhere where you'll either have to travel and you'll have to account for the different types of power, and if you're designing stuff, you have to account for that as well. And then of course it could change over time.
Mhm.
All right, so there's a thermistor. A thermistor is the one with the T, but we don't know if it's a thermistor UK or a thermistor US Canada. All I'm going to do is just excuse me, is just do some Google searches on these just to get the symbol, the universal symbol.
Okay.
Thermistor US. All right, so this one. Okay, so this one is the Thermistor US. I don't know how you want me to label these. A is the thermist. No, I'm sorry. D is the Thermistor US. That first one. Is that clear?
Yeah.
Okay, and then the UK one, the Europe one, which it's kind of anyway. That's C. They use that. I don't know why. That's the way they do it. It looks like there's even other. Wow. I hope this is right. There's even another thermistor thing I'm seeing. Okay, let's move on to variable resistor US. So your variable resistor is the B. This one right here. Sometimes it has a line actually through it. That's what I was looking for initially, but I didn't see it. And then we've got a variable resistor UK or Europe. Europe is UK is part of, well, still part of Europe, but I think that's changing. So that's the A. The A, they use that symbol there. Okay. And then we've got two light dependent resistors. So one of these is going to be US, one is going to be a UK. I'll just look those up here. Light dependent. Okay. Which one is the US? Which one's the UK? Oh boy. They're showing me both images every time I'm looking this up, so it's very unclear.
Oh, okay.
I'm sure this is obvious to someone that does this all the time, but I mean, I don't even know. Come on, give me something here. All right, I guess I'll go just to be consistent. I really can't actually give you the answer because I don't. The one I'm seeing a lot of is this one for the US, but that's more consistent with the UK. Oh boy. LDR symbol. Oh, there it is. I finally found one that compares it. Okay, so here we go. The this is the E is the UK. That's the UK one, and then F is the USA.
Okay.
All right, so which of the following are proper uses of a thermistor? It's a very textbooky type of question. I have no idea. So let's take a look here when you would use one or not. So they're often used in temperature devices. So I guess I would go with these and then the overheating one.
Okay.
Thermistor. Therms, obviously. All right, back to so I think they're used to measure. They don't actually like protect you from anything. So a thermistor would simply indicate something that's going on. It doesn't like shut off when the pressure is well, it does say protection, but not from oil impurities. Sorry. Okay, so now I see. Prevent the car or oil temperature from overheating. Yeah, it's just a sensor. It's just a sensor. So it's not going to do anything more than just indicate what it's doing.
Okay.
Okay. Another thing here. All right. All right. So next thing I'm seeing here that you sent over. Okay, so again, you want to do the ones that are maybe the we've talked about the most, and the ones we've talked about the most are the circuit breaker and I guess the capacitor. So the capacitor, we talked about how it stores energy in a circuit. It's a pretty standard thing.
Mhm.
Okay, and then the circuit breaker, we talked about how it has an electromagnetic switch. Okay.
Okay.
And a potentiometer, let me just double check. Okay, sorry, there's and so the light dependent one, see how it's got a light, talking about light going with it, resistance decreases when light falls on it. That's the
Mhm.
light dependent resistor. So it makes sense. And the potentiometer, I was looking for something else, but it does alter the flow of current in a circuit. And so you try to do the ones that maybe are the most clear to start, as you probably already know. And when you get in most tests, when you get 4 answers, they're 4 different ones. It's you wouldn't normally have double up, although instructors do just about anything they want these days in college. So those rules go out the window.
Mhm.
Okay. Transformer is used to step up or step down the voltage. They're for voltage.
Okay.
That's just a standard thing that they do. Okay, what hazard can arise? Hazards when the current flowing through the circuit is too high. So that means there's just too many electrons flowing through the wire. The first one is that it'll get hot. You'll notice that immediately. If it gets hot, you can melt the insulation, which can potentially cause a fire. Okay.
Mhm.
The next ones are kind of like the first 3 kind of lead to them. Sounding of the alarm. Yeah, I mean that could happen because it could be leading somewhere. Poisonous fumes could come from melting. I don't have a good way to direct you beyond for sure those things, but that is what happens if you leave your your computer plugged in for a long time, you'll notice the wire is warm, or if you have something that's always plugged in, it gets pretty warm, and
Mhm.
you sometimes notice these things. I mean, you don't have poisonous fumes in your house, but anything melts, things kind of deteriorate pretty quickly. All right, so next question here. We've kind of already answered this, so this will be pretty quick. Okay, so other than fuses, which other device could be fitted into a circuit to protect it from excessive current flow? Just talked about that. The circuit breaker does that.
Okay.
All right. Okay, so we're up to I think 20. I'm on to a new email. Okay, which of the following is the correct transformer equation? So well, it's definitely not this one. It's one of these 3. I mean, we talked about it verbally. It's that as the turns increases, the voltage increases. But I'm actually not sure how it's written. So let me look that up.
Okay.
Transformer equation. It's most commonly represented VS over VP or VP over VS, NS. Okay, so this would appear to be the most common way that it's represented. This is just a textbook thing. You'd find that in your notes somewhere on that.
Okay.
Oh, and then 21. That's good. That goes on to have us match. And the P, so the P stands for the word primary. So VP would be the voltage or the primary or primary voltage. S is secondary, so voltage of the secondary. NP is the number of coils, so that the number of coils primary. NS is the number of coils for the secondary. And these coils, they actually go around, well, it's usually represented like this. You have a primary and then a secondary.
Okay.
How these are actually implemented in real life, I don't know. You know, these things just sort of work. And maybe you know, when these were first generated, they actually had wrapped coils, but I don't know that it's that way now. Okay, so as the turns increases, the voltage increases. So that would be a step up transformer. It's this, if it were to decrease, then it decreases. Okay, so the primary coil has 1,000 turns, and it's 150 volts, and we want to get down to 6 volts. So we need to figure out the number of turns.
Okay.
So obviously it's going to go down because you're going down quite a bit to go there. So what I would do is figure out, you know, either how you go from 156 or 6 to 150, however that math works for you, because it's not about the math here. It's about just like what is it, and it's 25. So you can divide by 25 here. So you're subsequently dividing by 25 here, which would give you the 4 turns. I'm sorry, the 40 turns that you need. No. Yes, sorry. 40 turns that you need for this.
Okay.
All right, we got another image here. You can look at. All right, so name each part of the transformer symbol. A is generally the primary, C is generally the secondary, and B is the core. And these are represented in other ways, but this appears to be the way your class is doing it. All right, and then we got one more email here. Okay. All right, so we got, first one here is just some words that go along with explaining why a transformer cannot work with DC current. Okay. Explain why a transformer cannot work with DC current. So one of the things we could talk about with a DC current is that DC current only flows in one direction. Okay, that's one thing to say. And we just talked about a transformer. Transformer can either step up or step down. Okay. And the main thing when you're answering questions like this is to never copy and paste from the internet, as you already know, but you want to just include, they're looking for the right words here. You know, do you say these things? This transformer can step up or step down the voltage. Okay. And a DC current only flows one direction, which is bad. That's not what it wants here. So let me see if I can find a few more things to help answer this. Another thing is here is that DC cannot change in current. And that's an important thing that happens here as well. What else can we say? There's no relative motion between the coils.
Okay.
We've kind of talked about that, moving back and forth. Okay, so the next thing here, and I guess that's probably the last, is to talk about the function of the core. So the core is what is between the primary and secondary coil. So that's the first thing we'll start with, is that the core it's between the primary and secondary coil. All right, so that's kind of a first thing we can talk about. Now, what is it made of? Now, okay, so let me just add a little more to that. What is the function of the core? What is it made of? So we can just sort of talk about the definition. We can say that it allows the voltage to step up or step down, and this is in a transformer. So there's a few different types of materials that it's made of. You may want to check with your notes. I'm seeing iron as like a common one, but you want to be careful not to give an answer that isn't in there. They also talk about the fact that it's sometimes layered rather than solid.
Mm-hmm.
And I would just be careful not to use words that they're not expecting here.
Okay.
And the reason is and this kind of closes out the answer. The reason it's made of this material, there's a complete linkage of magnetic flux, which is required for the step up or step down through the core. So that kind of closes out that. So if you somehow get all that together, it will definitely indicate that you're followed the notes in the book with
Okay.
how to answer this. All right, so that I think is it for today. I think we got through everything that you wanted to get through.
Yeah.
I know we got something scheduled for tomorrow. And I'm also going to send you out the SAT prep week 1, start tomorrow as well. If that works for you.
Yeah.
Great. So thank you so much and glad to help. I'll see you next time.
Yeah. Thank you so much.